Alright, this is part 2 of section 4.1. And before I go over some examples, kind of want to maybe just go over sort of like a flow of how these problems usually are solved. First is if you're given for the integral, you usually want to rewrite the problem to be able to see the exponents as far as if it's a radical or maybe a negative exponent if it's power of x in the denominator. And then you want to apply the appropriate integration rule. It's usually going to be either the power rule or one of the trig functions. Okay, so whatever the case may be, you apply the appropriate rule, and then simplify as needed. Any fractions that have to be simplified or reduced, if there's any radical or fractional exponents, or maybe negative exponents that need to go in the denominator. Alright, so hopefully this gives you kind of a mental outline or a procedural step-by-step process through most of these integration problems. So this is going to be an extension of what we did in the last video, which is finding antiderivatives, but then now we're going to be finding something called a particular solution. So you're going to be finding an antiderivative, and you're going to be told that it has to pass through a certain point. So think of this order over here as your x and your y. So this is called your initial condition. And what it kind of just says is that once you find g of x, that you're going to solve for c to make sure that it passes through the point 1 for x and the negative 4 for the y. So this is the x coordinate, that's the y coordinate. Alright, so I find my antiderivative as I would before. So g prime with respect to x is, this is 8x to the third. This exponent is x to the 1/2. This is 1 over x to the third, so it's x to the negative 3. So in this stage, I'm doing the rewrite in terms of exponents to be able to use a power rule on these terms. And I go ahead and power rule on x to the third. If I add by 1, it's x to the 4th all over 4. The power rule on x to the 1/2, I'll do it over here on the side. X to the 1/2 is 1/2 plus 1 all over 1/2 plus 1, which is x to the 3 over 2, all divided by 3 over 2. Anytime you have a fractional exponent, the denominator is going to flip. So now it's 2 over 3, x to the 3 over 2. Adding this power by 1, we'll do it over here on the side. It's going to be x to the negative 3 plus 1 all over negative 3 plus 1, which is x to the negative 2 all over negative 2, plus my arbitrary c, plus my constant of integration. Alright, so now I'm at the last phase. I have to simplify as much as needed. This is a fraction I can reduce, so it's going to be 2 x to the 4th, 2 over 3. The problem started as a radical, so I want to end up as a radical, so it's going to be radical x to the 3rd power minus 1 over 2 x to the 2. X was being raised to the negative 2 because the negative exponent, it goes in the denominator, and this is really the coefficient of negative 1 over 2, so that's why it's negative 1 over 2 plus c. Alright, so now I have my antiderivative, but I want it to pass through the point 1 and negative 4. So I'm going to apply my initial condition. So all this really means is I plug in 1 and negative 4. This is going to be now, g of 1 is going to be 2, 1 to the 4th, plus 2 over 3, square root of 1 to the 3rd, minus 1 over 2, 1 squared plus c. Make this a little bit nicer for you to be able to see and read. And then this all has to equal a negative 4. Simplifying this, this is 2. 1 to the 3rd power, and the square root of that remains 1. 1 times 2 over 3 is 2 over 3 minus a half plus c. Over here the side I'm going to simplify 2 over 3 minus a half. Common denominator for 6. This is going to be 4 minus 3. So 1 over 6. So negative 4 is equal to 2 plus 1 over 6. This becomes 13 over 6 minus 4 plus c. Subtracting this over, this is going to be negative 4 minus 13 over 6, so negative 24 over 6. And this simplifies to be negative 37 over 6. Alright, so now that I have my c value, what I have found is my particular solution. So that's going to guarantee that this g of x, once I plug in this c value, is going to pass through the point 1 and negative 4. So I can write my particular solution as g of x equal to, so what we found previously is our antiderivative, 2x to the 4th plus 2 over 3 cube root of x to the, square root of x to the 3rd minus 1 over 2 x squared minus 37 over 6, and that's my particular solution. So all that we kind of did was just extra bit of work to find the c value, and that's it. Alright, next example hopefully isn't as long, but it might be. I don't know, I haven't worked these out yet. Same thing, I have to find my antiderivative, so I'll just jump right into it. It's going to be f prime dx is equal to the integral of 5x squared minus secant x plus x to the negative 1/2 plus 3 e to the x. Now the reason I didn't touch this secant squared, the reason I didn't rewrite any of this is because secant squared, I know that's an antiderivative rule, so I don't need to touch it, because the secant squared antiderivative is just going to be tangent. And the fact that it's a radical means it's going to be a 1/2 power, and the fact that it's in the denominator makes it a negative exponent. So that's how I got from here to here. So next thing is going to be appropriate rule for each term. This is the power rule, so it's 5x to the 3rd all over 3 minus, and like we said, the antiderivative for secant squared is tangent, so it's going to be minus tangent of x plus power rule on x to the negative 1/2. I'll do it over here on the side. This is x to the negative 1/2 plus 1, negative 1/2 plus 1. I go ahead and simplify this. This is going to be x to the positive 1/2 all over 1/2. When I reciprocate 1/2, it turns out to be 2. X to the 1/2 power plus 3 e to the x plus c. And in case you forgot, the antiderivative of e to the x is itself e to the x. And not much simplifying if needed. All I need to do is write this as a radical. So my general antiderivative is 5 over 3 x to the 3rd minus tangent of x plus 2 radical x e to the x plus c. I now need to apply my initial condition. This over here given to me is the initial condition. When I plug in 0, I want the function to equal 8. So now it's going to be f of 0, it's going to be 5 over 3, 0 to the 3rd power, minus tangent of 0 plus 2, radical 0 plus 3, e to the 0 plus c. And luckily a lot of stuff cancels out. All this is going to be a 0. Tangent of 0 also is 0. 2 square root of 0 is 0. However, e to the 0 power is going to be 1. 1 times 3 is going to be 3. So this simplifies to just 3 plus c, and I need it to equal 8. So I set it equal to 8. And so I just subtract this over, so 5 is equal to c. So my particular solution is my antiderivative with my c value that I solved for. So my particular solution is f of x 5 over 3x to the third minus tangent x plus 2 square root of x 3 e to the x plus 5, and that's my answer. And we're done.